Okay, so for solving radical equations, here's kind of the big things that you're going to have to do. You're going to get the radical by itself on one side of the equation. Okay, so you're going to have third root, fourth root, fifth root, whatever the radical is on one side, you're going to have some expression on the other side. And then once you've got that part of it, you're going to raise both sides to the power of the index. Okay, and that's really everything we're looking at. Now, what we're doing against some situations is where if they don't give you a radical, we'll look at that one and kind of show you what's happening with it. But mostly that's kind of what we're looking at as we go through this thing. One small little note as you're going through these. Remember, you cannot have some even index of some expression, some number, whatever it is that you've got, equal to a negative number. Okay, third root we're okay, fifth root we're okay as we're going through these, but you cannot have an even index, an even root equal to some negative constant. Negative numbers, okay, we can do that, or negative x or something along those lines. But if it's a negative number, just a negative constant, you cannot have that because that's going to give you a imaginary number. And in this case, we're not worrying about any imaginary solutions. Everything in this case has to be real number solutions so that anything we're going to do, we need real number answers. We don't need anything imaginary for this part of it. Okay, so we'll take one back to something really simple that we've kind of done in the past. If it was square root of x equals 3, what did we do in that case to get this thing to be just x? Yeah, just raise both sides power 2, right? Because it's x, because technically if it's square root, it's the second root of x. So to solve this thing, all we had to do was just raise everything to the second power. Yeah. And again, the purpose of doing that is that if this is a square root and that's something squared, then those two things knock each other out. Leaves you with just the x. We'll do 3 squared and we make it 9. Okay, so if it's fourth root of x, just a little different spin off of it, because you probably won't get very many of these short ones like this, but just make sure everybody's okay. If it's fourth root of x equals 2, again, if it's fourth root, we need to raise everything to the fourth power. Okay, and again, fourth root, fourth power will cancel each other out, leave you with just the x. Then we'll do 2 to the fourth power. Run through your powers of 2, that should be 16. Okay. And then they'll start to get a little bit longer with a little more variety of different parts and pieces. This thing. All right, so let's go with square root of 4x plus 1 minus 5 equals 0. All right, so very first thing is we've got to get rid of this negative 5. So we want the square root to be by itself. So we've got square root of 4x plus 1 equals 5. And again, because it's the square root, we need to square both sides. Again, square and square root cancel each other out. That leaves us 4x plus 1 equals 25. We'll subtract the 1 from both sides, so we get 4x equals 24. And then divide by 4, so we get x equals 6. Okay, so the same concept. No matter what it is, just use your index to help you know what power you've got to raise both sides to. Okay, let's give you one more before we do something a little bit different. So let's go third root of 4x minus 3 equals third root of 7x plus 5. Okay, so very first thing on this one is, you should notice that we've got two radicals this time. And for this part of it, now the good news on this one is you've got two radicals. They're both to the third root, so they're kind of good for that part. And if it's just one radical equal to itself, and as long as the indexes are the same here, then basically you can just take out what's on the inside. If it's a balance, then 4x minus 3 has to equal 7x plus 5. As long as the indexes are the same, then you can almost think about it. Again, if we take both of these things to the third power, then these cancel each other, these cancel each other. You're left with 4x minus 3, 7x plus 5. Okay, and then from there, now it's just a normal, regular solving equation. We'll get rid of the 4x. So we've got negative 3 equals 3x plus 5. Let's subtract the 5 from both sides. And then divide by 3, so we get x is equal to negative 8 thirds. Okay, so two different radicals. In this case, it's okay because, again, they're both to the index, same index. So if you raise them both to the third power, in this case, because the index was 3, everything cancels out. You're left with just the expression that's on the inside, and then just set those two things from there, and it's just a regular solving equation. All right, now here's where things start to change a little bit. Where it's, even though we're doing radical equations, it's not written in a radical form. That they change this thing and change it so instead of being in radical form, it's more in exponential form. So it'll be more like what we were doing in the last lesson. All right, so for this one, we're doing 3 times x plus 1 to the 2/3 power equals 12. Okay, so there's two different ways you can look at this one. I'm going to show you probably the better way to start thinking about these problems, because some people look at this and go, well, there's no radical in this thing. We've got this fractional exponent that's here, but there's not a radical. But again, you've got to go ahead and remember that if this is the 2/3 power, this is still like the third root. So it's just a different version of it being written this way. So basically, here is your radical here. So we need to get this by itself, which means we need to get rid of this 3. So the very first thing we would do is divide both sides by 3. Okay, because again, you're still trying to get x by itself. In this case, the x just happens to be in a radical part of it. And from this part of it, here's where we're going back to whatever something grade math it was would be in this part. that if we've got x plus 1 to the 2/3 power, again, this is still like your radical part that's here. We need to get this thing so it's down to x plus 1 to the first power. So if we've got x plus 1 to the 2/3 power, what can we put power-wise out here that would cancel this out so we're left with just x plus 1? Got to go back to your power rules there. What can we put out here that would make all this stuff cancel so we've got, again, just x plus 1 to the first power? Anybody got a thought? Wait, there it was.
3/2?
Yes, 3/2. Just use your reciprocal power, right? So if you got 2/3, if you raise that to the 3/2 power, 2's cancel, 3's cancel. We've got x plus 1 to the first power. We just got to remember to go ahead and do that same thing over here. So it's going to be 4 to the 3/2 power. Okay, so we've got 4 to the 3/2 power. This is where you can either rewrite it and simplify it. You can use your calculator, ever how you want to do this one. But again, if you think about how that is, this would be the square root of 4 to the 3rd power. Because again, we put the index of 2 here. Square root of 4 we know is 2. 2 to the 3rd power would make that out to be 8. So that's x plus 1 equals 8. And then quick, easy solving there, subtract 1 from both sides, we get x equals 7. Okay, so again, it's still a radical expression, but the exponent's not in radical form. It's going to be in this fraction form that we're looking at. So for that one, if you can remember that if you can isolate this by itself, just use your index you've got, but just use the reciprocal power of it. And again, that's because you're going to multiply these things out, so then we cancel everything out, and we've got x plus 1 to the first power. Okay, so let's do this. Let me give you one here for that same kind of concept. And try that one, see what you can come up with. And then check your answer, see what you get, and then we'll double check it and just kind of see what we can get there. All right, let's see what we got here. All right, so first step, again, got to get this x by itself, so we're going to divide everything by 2. Should give you an x plus 3 to the 2/3 power equals 16. Okay, and then same concept on this one. Again, if you've got whatever the power is, we're just going to take that power and multiply by the reciprocal power. Again, cancel, leaves you with an x plus 3. And again, this is one you can either check it on your calculator. You can put in 16 to the 3/2 power. But again, that's basically the square root of 16 to the 3rd, which is 4 to the 3rd, which is 64. And we'll subtract 3 from both sides, and that should give you an x equals 61. Okay, now here's where we start getting around some little tweaks, little turns, little twists, gotta be careful on these. Because here's where what's on the inside of your radical or your fractional exponent gets a little more complicated, which means our answers may get a little bit more complicated as we go through these. Okay, so we've got x squared plus 5x plus 5 to the 5/2 power equals 1. Okay, first step, still the same thing. We've got the 5/2 power, so we're going to raise this thing to the 2/5 power. We're going to raise this thing to the 2/5 power. That is 5/2, yes. Okay, so we've got 5/2. We did it by the 2/5. Again, everything cancels. We're left with x squared plus 5x plus 5. The good news is with 1 to any power, it doesn't matter what it is. It's still just 1. You're like, okay, well, what's different about it? Okay, so here's where it gets a little different. The other problems we basically had x plus or minus something. This one we've got x squared. So if that's our problem, how many answers are we looking for now?
2.
There we go. Looking for 2 answers, right? Because now we got x squared, so we're going to have 2 answers. Which means, guess what we get to do? Everybody's favorite thing to do. After we bring the 1 over, of course. Oh, there we go. We're going to do some factoring. Yeah. All right, so Eli. Okay, so we are going to have to factor. Now, the good news is the factoring in this case should be fairly easy factoring. Because what are the factors of 4 that equal 5? Yep, got to be 4 and 1, right? So in that case, x, and they're all positive, so it's x plus 1, x plus 4 equals 0. If we solve these two equations, set that equal to 0, we're going to come up with, right at the bottom here, x equals -1, and then x equals -4. Okay, now, and when you start to get multiple answers, this is where you've got to start, and we're going to throw out a new term here in just a second. We're going to talk about extraneous solutions, where we've got to go back and check that. And I think we may have talked about that one possibly. But they'll start saying to check your answers, and that's kind of your cue, your hint to know that, okay, some of the answers I've got may not always work, so you're going to have to go back and start playing around with some of those answers. Okay. All right, so here's one where we get a little different look on this one. So we're going to do x plus 18 to the 3 over 2 power. And that's going to equal x minus 2 to the third. Okay, and hopefully the first thing that jumps out at you is you go, wait a minute, we've got 2 different powers here. We do. So let's do this first. Let's get rid of the most complicated part first, which would be your fractional part. So for this one, let's take the x plus 18 to the 2/3, or to the 3 over 2 power, and let's raise this to the 2 over 3. Because a lot of times these fractions look kind of scary, so let's get rid of the scary part first. And again, we've got 3 over 2, the 2 over 3, all that cancels. That gets us down to x plus 18 on the left side. Okay, and then on the right side of this case, it actually works out pretty well for the right side of it, because on the right side, when we do this, it's 3 over 1. So when we do 3 over 1 times 2 over 3, 3's cancel, and that'll leave us with x minus 2 squared. Would have been better if I'd had that power a little higher up there. Okay, so for this one, you're going to have to do a little bit of full method, a little double distributed property. Again, it's not just x squared and then 2 times 2 for 4. We do have that, but after we do the full method, do some double distributed property there. We've got x times x for x squared. We've got a negative 2x here. We've also got another negative 2x there. So that would actually be a x squared minus 4x plus 4. So kind of a good section because we're reviewing some factoring, we're reviewing a little bit of full method, a little bit of double distributed property, and still doing some solving equations along the way. And so for this one, we need to get everything over to one side. So let's do a negative x and a negative 18 here. So we want this side equal to 0. Negative 4x, don't forget that's technically a 1. So negative 4 minus 1 is negative 5. 4 minus 18 is negative 14. Okay. And again, the factoring should be I don't think we're going to have to worry a lot about the AC method of this. Most of the factoring should come off that you've got x squared. So in this case, we're looking for the factors of negative 14, where the sum is going to equal negative 5. And again, with 14, there's only two options. It's either 1 and 14, 2 and 7. We know the 1 and 14 is not going to get us there. So then it comes down to where do the signs go? Again, your B term is negative, so that's got to go with your bigger number. And if you divide a negative and a negative, it makes the smaller number a positive. So this one should be x plus 2 and x minus 7. So there's our factored form, but again, we need to solve it. So we'll set x plus 2 equal to 0 and x minus 7 equal to 0, which means we'll get x equals negative 2 and then x equals 7. Okay, so again, the easy ones in the beginning are pretty straightforward. It's when we start getting a little bit more complicated exponents, and really when it comes down that we've got more complicated for the radicands after we take them out, that we get those little problems that run in there. Okay, one last example, and then we'll be done. And here's where the directions change a little bit. They're going to ask you to solve, and then we're going to check for extraneous solutions. All right, here's the big catch for this one. Whenever you see check for extraneous solutions, when we're talking about what extraneous solutions are, these are answers that do not work. All right, so now set up what we're going to do for this one. We're still going to go ahead and do our normal top problem on this one when it comes off of it. And again, we're only going to have one example here. So we got square root of 5x minus 1 plus 3 equals x. We'll do like we were saying earlier. We still need the radical by itself. We'll subtract 3 from both sides. All right. So first step, still the same thing. We've got the radical by itself. Second step, still the same thing. It's the square root, so we're going to square both sides. So again, we square root the square, or square the square root. That's going to leave us with 5x minus 1. Now, on the right-hand side, here's the difference on this one. Everything we had done before, we had like 3 or negative 3 or 5 or something like that. In this case, if we do x minus 3 squared, again, you have to do the full method. You have to do that double distributive property here. So when we go through and do that one, we're going to be left with x squared we know we're going to get 3 times 3 and get 9, but we've got a negative 3x and a negative 3x. So it's going to get us x squared minus 6x plus 9. All right, and again, with x squared, we know we're looking for 2 answers, so we've got to do some factoring, which means we need to move this over to the right-hand side and also the plus 1 over to the right-hand side. All right, so that leaves us with x squared minus 11x plus 10, and that's equal to 0. So that's where, now, this is still where we're still like we're doing some other examples. We're still going to go ahead and factor. And the good news for this one is the factoring is easy. The factors of 10 that will get us 11 will have to be 1 and 10. In this case, they both should be negative, so that's going to be x minus 1 and then x minus 10. Okay, so we've got x minus 1 equal to 0, x minus 10 equal to 0. Again, the solving is easy. Add 1 and add 10. But again, the directions in this case said you have to check for extraneous solutions. And they basically they're saying, okay, do these answers really make sense? Does it actually work when we go back and plug it back in and we check? Because again, a lot of times things look like they work, and then when you check it, you go, wait a minute, that really didn't come out like I thought it was going to. So we're going to take that, plug it back into the original equation, and see if this actually does give us two equal equations. Okay, so plugging in x equals 1. So we've got 5 times 1 minus 1 plus 3 equals 1. So that's the square root of 5 minus 1. That's the square root of 4. Square root of 4, again, math is easy. Square root of 4 is 2. Does 2 plus 3 equal 1? Last time I checked, no, right? So even though we got an answer, this answer, when we check it, it doesn't make any sense. So this answer is out. It's not going to work. Okay, now, and don't assume anything, because just because 1 didn't work, go, oh, a 10 has to work. Well, maybe not, because sometimes it may be that neither answers are going to work. You have to kind of check and see what's going to happen for this thing. So this one will do the same thing. We're still got to plug in the 10 and see if it works, because it may or may not work, just depending on the problem here. Okay, so we've got 50 minus 1, so that is the square root of 49. Plus 3 equals 10. Square root of 49 is 7. Does 7 plus 3 equal 10? Yes, it does. So in this case, 7 actually works. So for this one, with x equals 10, that's our only solution. Because again, x equals 1 didn't work. All right, now again, worst case scenario. If you check these, let's say we had checked this one and we got 7 plus 3 equaled 100 instead of 10. If that came out that this didn't equal also, if neither answer works, then basically that answer would be that there is no actual solution for this thing. So there is a possibility that you may get through the work and do these, and there may not be an actual answer, because if you check both of them and neither of them work, then it's no solution. Now in this case, again, we had one that worked, so we got one solution instead of two solutions to get what we needed.